Hey everybody, I hope everything's going well. So today I was going to show you some more cool stuff in multiple regression with these dummy variables. As you see, I have a couple of those same ones over here. So today we're going to motivate this video with an example of how do gas prices depend on oil prices. Oil prices, oil is the stuff we get out of the ground, out of the wells. That goes to refineries and is turned into a bunch of different products. One of the major products is gasoline, the stuff we put in our cars. And of course, this could have a lot of business applications because there's a lot of businesses, of course, that depend on oil prices, gas prices, on both sides of the equation. Selling oil, buying gas. And so this is a really good example of how we might use these dummy variables and might be related to some of your projects. So in this data set, we're going to have gas and prices from California, Massachusetts, and Texas, okay? So right here, I've just written out what a data set might look like. I'm gonna show you the actual data set for this in Excel in the next video. So that's gonna solidify a lot of the stuff that I show you today in the algebra. So right here, we have gas prices. That's our Y variable, our dependent variable. Then we have oil prices. That's going to be our main independent variable, the one that kind of we care about the effect of that. But to make a good model, we might want to include some other control variables. For example, maybe California has higher or low gas prices than Texas or Massachusetts for some reason, and we could use a dummy variable called California to account for that. Notice that California is a categorical or dummy variable because it's like, did this observation of gas price occur in California? That is a yes or no question. So right here, our first two observations, where we have one for California, did occur in California. But then these ones down here where we have zeros did not occur in California. I can add more than one dummy variable to a multiple regression analysis. I made another dummy variable called Massachusetts, MA right there. Of course, if this observation is in California, it couldn't also be in Massachusetts, so that's a 0, 0. And then we see down here, in this example data set, this is just a little piece of the overall data set. Right here we have 1s for Massachusetts, so that tells us that these two observations of gas prices occurred in Massachusetts, okay? Notice I told you we also have data from Texas. I actually wouldn't want to write another dummy variable for Texas because you always want to leave one out as your baseline situation. Because if you have 3 states, and so these two cases right here are not in California and are not in Massachusetts, so where must they be? They must be in Texas. By including another variable in this data set called Texas, I would be including extra information. I'm also going to introduce a new kind of cool thing we can do with the dummy variables today, which is called interaction. We can interact a dummy variable with another numerical variable, or really we could interact 2 dummy variables together. But in this case, I've taken Massachusetts times oil price. So over here, well, Massachusetts is 0, oil price is 20.41. 20.41 times 0 equals 0. So notice those are 0 everywhere where we have zeros for Massachusetts, but then down here, 1 times oil price is oil price. So with 25.16 times 1, we get 25.16 again. All right? And I'm going to show you how the algebra on that type of variable can work out in this video, in addition to kind of reiterating these other ones. So let's think about our population regression equation real quick. So we're going to have our dependent variable, gas price, right there. That's going to be equal to an intercept, beta naught, plus beta 1 times our first independent variable, oil price, plus beta 2 times CA, plus beta 3 times MA, plus beta 4 times MA times oil price right here, okay? And so just like last time, once we have our main regression equation, we can write down different equations for different values of the dummy variables, because that's pretty easy when those variables only take values of 0 or 1. In this case, we're going to have 3 equations. We're going to have a Texas equation. We're going to have a California equation. And we're going to have a Massachusetts equation. Our Texas equation is going to be the simplest one, because in Texas, the variable CA and the variable MA are both 0. So in this equation, I'm going to have gas price equals beta naught plus beta 1 times oil price. California is 0. 0 times beta 2, that's gone. That drops out of the equation. That won't appear in this Texas equation. Massachusetts is 0. That's going to disappear. Notice right here, Massachusetts shows up again. It's going to be 0. This whole term is going to drop out. So actually for Texas, we just have a simple linear regression version. We have gas price equals beta naught plus beta 1 times oil price. Remember how dummy variables change the intercept for the different dummy variable numbers? Well, in this case, beta naught is going to be our baseline intercept. We're using Texas as our baseline, so beta naught is the Texas intercept, is how you can think about beta naught in this equation. Now for California, we're going to have gas price equals. Last time we showed that when we collect like terms, our beta naught is going to get collected with this beta 2, because California is 1 in the California equation. 1 times beta 2 is beta 2. Then beta naught and beta 2 are like terms. So just like that time, beta naught plus beta 2 is going to be the intercept for California. Added those together, that's the intercept for California. Beta 2 is the difference in the intercept between Texas and California. Okay? So now, Massachusetts is 0 in California. That's gone. Massachusetts is 0 in California, so that's gone. But I still have my beta 1 oil price right here, because that is not being multiplied by any dummy variable. So that sticks around. So finally, the Massachusetts equation, gas price equals, well, what's Massachusetts intercept going to be? California is 0 in Massachusetts, but Massachusetts is 1 in Massachusetts, so beta 3 times 1. Beta naught plus beta 3, right there, that's our intercept for Massachusetts. But now I can do something special. Notice here Massachusetts is going to be 1. 1 times beta 4 times OP is just beta 4 times OP, oil price. So I can just turn that into a 1. But notice now I have another like term in this equation. Beta 1 times OP plus beta 4 times OP, those are like terms because they're being multiplied by the same variable. So by including this interaction term, not only am I allowing Massachusetts to have a different intercept, I'm also allowing it to have a different slope. So plus beta 1 right there plus beta 4 times OP. So that's the cool thing about these interaction variables. They'll allow you, after collection of like terms, to have a different slope for some reason. Maybe you see something in the data that makes you believe, hey, this state should have a different slope. Gas prices in Massachusetts look like in my scatter plot that they might react to oil prices in a different way than Texas and California. And we'll definitely look at something like that in the next video, where I basically do this with real data in Excel. And that'll help make sense of a lot of this stuff. Because remember, what's going to happen, this is all the theory that underlies what we're going to do. We're going to go actually get our hands on numbers for all of these different equation parameters, slopes and intercepts. Okay? So this is probably worth trying to write down on your own and thinking about how I collected these terms. Try to write this out with your ones and zeros before collecting like terms, and then convince yourself that after you collect like terms, you should get these three equations for Texas, California, and Massachusetts. All right? So that's going to be it for today. I hope you guys are having some good time at home.
See you later.